Well, math analyzers, we have been looking at solving for missing sides in right triangles, figuring out missing angles in right triangles using trig. We've looked at special right triangles. We've looked at the Pythagorean theorem for finding missing lengths of sides. Now, we're going to put that all into play into our word problems. So here we go. I think you know your trig ratios by now. If not, of course, on here as per usual. And now what really needs to be stated is what is an angle of depression and what is an angle of elevation, because that is so key when you set up your problems. You always need to draw a picture of what's going on. And then when you read that it's an angle of depression, we're talking about down from your direct eye line. So that's this guy down there, object wise. And if we're talking about an angle of elevation, which I just feel like happens more frequently, but it is, right? This is your eye line, and this is your angle of elevation from your eye line. Okay. So this guy's showing you this fun little I'm on every restroom door guy, right? Looking up to the object, this is your angle of elevation. Here's your eye line. Down to the object is your angle of depression. So you can kind of go from there, right? And this one is really the same as solving a problem in regular trig that doesn't have all sorts of word problem pieces to it and real life applications to it, right? You need to read the problem, you need to draw the picture, you need to label the sides that you know, you need to label the sides you don't know with a variable, and then you need to apply the correct trig ratio, use the correct piece on your graphing calculator, be it the regular ratio or second and the ratio, the inverse function of the ratio, and then we make sure that it answers the question, right? Make sure you're rounded to the right spot. Make sure the answer makes sense in the question. Okay? Let's look at a few of them. Find, to the nearest degree, the measure of the angle of elevation of the sun when a vertical pole 6 meters high casts a shadow that is 8 meters long. Make a diagram. I can do that, right? So let's see. Here is the pole. Here is the sun. He is casting his rays and creating this shadow, casting his rays, creating this shadow of the pole. So here's the shadow of the pole. There it is. Shadow, pole. Okay. The pole we know is 6 meters, so we must be in any other country other than the United States. And his shadow is 8 meters long. The sun is probably at a little bit less of an angle of elevation than I just created, right? But your angle, right, is what we need to find. The measure of the angle of elevation of the sun. Okay, so here is your eye line, right? And the angle of elevation is this guy right here. So I'll label it theta. Okay, so there's the straight eye line. There's the angle of elevation to go to the sun. All righty. Well, let's see. We know the opposite side and we know the adjacent side. So opposite and adjacent means the tangent function, or tangent ratio, I should be saying. Tangent of theta is opposite over adjacent. And now let's plug in. So tangent of theta. Oh, that's the thing I don't know. That's right. I was asked for the angle measure. Opposite side is 6. Adjacent side is 8. So that means it's approximate, sorry. To the nearest degree, Okay, that means I plug in here and it's second in the tangent function, and it's 6 over 8, same as 3 over 4, by the way. I know this is a 3, 4, 5 right triangle. And that angle rounded to the nearest degree is 37 degrees. There we go. Oh, I guess I should have done all those down here, but fit it all up there. Look at how pretty my picture is. Be creative on your pictures. Come on. You got to draw them anyway. Have some fun with it. At a point on the ground 40 meters from the foot of a tree, the measure of the angle of elevation of the top of the tree is 42 degrees. Find the height of the tree to the nearest meter. Again, must not be in the United States. Again, we're using meters, right? So, okay. Classic tree. And here's a point on the ground. At a point on the ground from the foot of a tree, 40 meters from the foot of a tree. Boom. There we are. We want to find the height of the tree. So you can see it in my drawing. Good. Okay, we can see that. Because this angle of elevation to the top of the tree is 42 degrees right here. So we know the angle measure, and we want to know the opposite side, but we also know the adjacent side. Opposite and adjacent, tangent. And actually, by the way, I have noticed that tangent seems to be the one we use a lot here in these scenarios. Not every time, but tangent is a lot because we're talking about the opposite and adjacent and not necessarily the hypotenuse part of it, right? So the tangent of theta is equal to the opposite side divided by the adjacent side. So we do know the angle measure is 42 degrees. So tangent of 42 degrees equals x is the opposite side and 40 meters is the adjacent side. So cross multiply, you get 40 times tangent 42 will equal our x. And find the height of the tree to the nearest meter. Got it. Round to the nearest whole number. So let's go. Tangent of 42 times 40 meters is 36 meters. Height of the tree is approximately 36 meters. Good stuff. Yeah, I am going to keep them this straightforward. Okay, so don't worry too much. And maybe on your test, the diagram will be there. Practice. Let me know if you need help. Draw me cool pictures. My mom loves lighthouses, so on the lighthouse question that inevitably exists, please draw a nice one so I can share it with her. It'll make her day. I know. You have to know I come from somewhere weird, right? All right, guys. I shall be seeing you very soon. Good luck, have fun, and ask me if you need help setting up your pictures or solving for a missing length of a side in your pictures. Good luck. Bye.